Hey guys, welcome back to the channel. I still haven't received the hardware I need to mount the box to the back of the frame, so on this episode we're going to concentrate on the opposite end of the truck. I have a couple of things to do up here. Minor repair. This hinge on this side has a broken pivot I have to fix. But more importantly, this guy is still completely original, so it still runs the 8BA flathead V8, and it's still running a 6-volt positive ground electrical system. So those are two things we're going to change. We're going to convert it to 12-volt negative ground like every modern car. And by modern, I mean anything made after the early to mid-50s. And we're also going to take the points out of the distributor and replace them with an igniter. If you don't know what an igniter is, it's basically a conversion to go from the old breaker points ignition to an electronic ignition system. That way you don't have to do tune-ups as often on the guy. You can drive for longer periods between tune-ups. So if you guys stick around, I will walk you through these processes. Okay, so the two biggest parts to convert this guy from 6 volt to 12 volt is of course to get rid of our 6 volt battery and replace it with a 12 volt battery. And then we're going to replace the 6 volt generator with, ta-da, this Power Master unit that I got from Speedway Motors. So this is basically an alternator that identifies as a flathead generator. It's got alternator internals, which means that it makes 12 volt AC power that has to be rectified back to DC. And it's made to be a direct bolt-on to replace this guy. After that, there's a few more things we have to do wiring-wise to get it to work with a 12 volt negative ground system. But I'll walk you guys through that when we get to it. So for now, let's get this thing on. Okay, first hurdle, probably one of many. I guess the alternator needs to spin faster than the generator. The pulley on the alternator is actually small in diameter. So my belt is now too long. I'm going to need a different length of belt. Easy fix, but I'm going to have to go down to the parts store. Okay, so I won't let my mandatory trip to the parts store slow us down. Might as well keep going. I'm going to take apart the distributor, remove the points, and convert it over to electronic ignition. And there's a few more changes we have to do for the wiring because, like I said, we're completing a 12 volt conversion. And this thing still has the stock cloth covered wiring and it's not looking all good. There's a bunch of places where the wire is damaged, so I am rewiring this complete vehicle. Anyways, so let me bring you guys on this side so you can see a little bit more what we're dealing with. So as you can see, the plug wires are in less than ideal condition on this thing. So I had a new set anyways to replace them. Now before we take our distributor apart to pull out the points and put in our electronic conversion, it's important that we know the firing order and that we know which plug wire goes where, because we're going to have to put them back in the same spot, right? So on These later model flatheads, the 8BA, the distributor is turning in a clockwise direction, and the cylinders are numbered 1, 2, 3, 4 on this side, 5, 6, 7, 8 on the driver's side. So this should be number 1 right here, and this little tiny plug wire goes to that one over here, and the firing order for those is supposed to be 1, 5, 4, 8, 6, 3, 7, 2. So 1, 5, 4 should be the back one. Yes. 8, 6, 3, 3. Yes. 7, 2. That looks correct. So now we can take all of this off, take our plugs wires off, take our distributor cap off, and get to our points so we can do the conversion. Plug wires have been there so long that they actually corroded themselves to the cap. So of course I'm going to need a new cap and rotor. That rotor here, I don't know if you guys can see, it looks like it's seen better days. It has quite a bit of wear on there. It looks though as though somebody's been in there recently because it has a brand new set of points installed on there. But we are going to get rid of those completely just to get rid of the wear factor, right? In order for an engine to get spark, the coil has to get powered on and off. Every time it shuts off the coil, it actually induces a high voltage. That's what creates a spark. So old school point system was a mechanical way of switching the power on and off. And because there's actually a contact in there, the contact would wear. Like if you imagine how many times this thing fires when it's running for a couple of hours, right? There's a lot of wear that happens on those points, so that changes your timing. That's why older cars always needed a tune-up. So what our igniter does is we take off the plate that mounts the points. We actually put a little electronic module and we put a sleeve over the shaft that has a magnet on it. And then instead of having a cam that physically opens a switch, the magnet actually triggers that sensor electronically. So there's no actual moving parts and there's no physical contacts to wear. So that thing technically can run indefinitely. So that's what we're going to do. Okay, so I got the igniter in, but I can't quite finish because I'm going to need my cap and rotor. Got my alternator in, but I can't finish that because I need a belt. Oh, things are going great. So I'm going to keep going with the wiring. Don't worry, I won't show you the whole process. Like watching a guy wire a car is about as captivating as watching paint dry. But I am just going to give you a few pointers of what I'm dealing with. So on the passenger side, I'm going to replace the 6-volt starter relay with a 30-year younger 12-volt starter relay. It's basically the same thing, except this one is made for 12 volt, and that one only had a lead going to the starter button because it was the contact for the control side was internal to the battery cable, whereas this one has two wires, so I'm going to have to make a jumper from one of the control side to the main post where the battery cable is going to be, and then the starter button can engage the other side. Fairly simple on the passenger side. And here on the driver's side, I have the stock voltage regulator, which I won't need anymore because in our Power Master unit, everything is internal, everything is built in, and runs like a one-wire alternator, so all that can go. I also have a harness that goes to the horn and the lights in the front that will need to be redone. I have another harness that goes to power the stock generator and run the ignition system, so that's going to have to be altered and redone. And what else do we have? We have another one that goes to the back. Also, that's going to need to be replaced. So like I said, I'm going to tear all that stuff out, redo it. I won't drag you guys through it because it's too boring to watch. But I'll show you what it looks like when I'm done. Okay, so just in case you guys want to update one of these old vehicles to 12 volt, a few pointers. First off, you have to keep in mind, there's this thing that we call Ohm's law that helps us calculate how much loading we're putting electrically on a circuit, right? So if you go from a 6 volt system to a 12 volt system, every circuit you plug up to it is going to take twice as much amperage because you're giving it twice as much voltage, right? Ohm's law says that the voltage that you apply to it is going to be equal to the resistance, the electrical resistance of that load times the amperage it consumes. Like, keep the math simple. If we have a 6 volt battery and a 2 ohm light bulb is going to use up 3 amps. 2 times 3 equals 6, right? If we take that same 2 ohm lamp bulb but we send 12 volts to it, now it's going to consume 6 amps because 6 times 2 is going to equal 12. So every time you update to 12 volt, everything electrical, the amperage is going to go up, is going to double as well, right? So you have to make sure that your wiring is capable of handling that. If your wires are too small for the load that they get, that's when things get hot and they catch on fire. So anytime you update that, make sure your wiring's good. That's part of the reason why I'm restringing this entire truck, right? Because the stock cloth covered wiring was like in pretty sad shape. So this thing would have been plagued with short circuits everywhere. Because of that, there's also other things you're going to have to be careful for, right? If you notice any car right up to the mid-90s, I would say, if you ever take out the ignition switch on one of those guys, you'll notice that the wires in there are huge, right? They're like an 8-gauge wire. Because back in the day, the ignition switch was literally the ignition switch. Everything electrical in your car went through that switch. So when you put the car on accessory to listen to the music while you're parked there, everything that's on with the key in the accessory position, that electrical load was going through your ignition switch, right? These old guys are wired the exact same way, except this thing here, because it didn't have power windows, power mirrors, power anything, right? That switch is not all that big. So now, granted, in this one, we haven't added a whole bunch of options, but we do have an electric wiper, that kind of stuff. And like I said, because we doubled the voltage, we doubled the amperage. So in order not to overpower that switch and burn it up, what I did is I kind of wired it backwards. Like usually you send the power from the battery to one of the lugs on the back of that switch. And then another one of the lug is for ignition on and the other one's for accessory on. What I did is I actually wired it backwards. Instead of a positive feed on the center lug, I wired this one straight to ground. And then I sent the other two to 2 individual high amperage relays. I think I bought 100 amp relays, right? So I basically have my ignition switch now just controlling a main ignition relay and a main accessory relay, which is the way cars are wired today, like 2000 and up, right? And by keeping my relays close to my fuse block, I'm keeping all of my big 8-gauge wires as short as possible. Makes it a little bit cheaper to wire the car that way and makes it less likely to have an electrical fire. Same idea. Anytime you convert a car to 12 volts, you cannot run the stock ammeter. Well, I shouldn't say cannot. Technically, you can if you want to, but you got about a 90% chance the car will catch on fire and burn to the ground. So it's up to you. I'd rather not. The reason for that, again, is because the ammeter, oversimplification, electrical engineers in the crowd, don't come at me. The ammeter was wired a little same way as our ignition switch. Everything from that ignition switch would go through the ammeter, and the ammeter basically measured how much load the vehicle is consuming. So again, you're running all the amperage through that ammeter. That's why the gauge would read charge and discharge, right? As long as you weren't consuming more than what the generator was capable of charging, it would stay on the charge side. But if ever you were consuming more than what the generator could make, you would be using up all of what the generator was making and then kind of borrowing some juice from the battery. So that's why it would go to the discharge side, right? If you're running an alternator, you can't do that because technically your alternator can produce way more amperage than a generator ever could. So normally speaking, again, because we didn't add a whole lot of accessories, electrical accessories, maybe we would have gotten away with it. But if ever, I don't know, say you left your lights on and the car won't start, so you get a boost. The minute the guy disconnects his boost cable, that alternator would try to charge the battery. Amperage production would go through the roof, and then everything trying to go through your ammeter. At the same time, if you're driving at night with your new 12-volt halogen headlights on, your wipers on, and then you hit the brakes, chances are you might actually overload the ammeter, catch that wire on fire, have an electrical fire behind the dash. So make sure you don't wire the ammeter. Most people, what they do is they add a little aftermarket voltmeter somewhere in the truck so they can keep track of the charge system. What I did, because I'm clinically insane, is I actually took the factory gauge and then I removed the ammeter. I bought the cheapest voltmeter you could find on Amazon, which was $14. I drilled out the rivets that held the faceplate of the ammeter to the guts of the ammeter, took the voltmeter apart, bolted the voltmeter's guts to the ammeter's faceplate, and then modified the bucket so I could actually fix the whole thing and try to make the dash look as stock as possible. Now the rest of my gauges are still going to work on 6 volts. And the voltmeter will work on 12. The reason for that, again, is because if you want your stock gauges to work, they were calibrated off of the stock sensors to work on 6 volts. If you double the voltage, you change the readings on those gauges become inaccurate, and chances are you would probably fry them in a short period of time. So to do that, I bought this little guy, which is a simple DC to DC converter. You can buy them on eBay, Amazon. They're not that expensive. So this guy here, I'm going to shove 12 volt to it on one side, 6 volt comes out the other side. So I'm going to feed my gauges off of this guy. Just be careful when you mount this guy in the car. You can see this thing has 2 fairly big heat sinks on it. This little sucker gets insanely hot. So be careful where you mount it. Make sure there's nothing flammable nearby. Make sure it's not hanging out where your passenger is going to burn their knee on it, right? I'm going to mount it to one of my 2 braces because this truck, like most work trucks, didn't have a radio in it. So I'm going to mount it in back of the radio block-off plate to one of the original dash brackets. And as far as the generic wiring of the truck, I just bought a universal 14-circuit fuse panel and wiring kit, and I made my bracket to mount it up here, tucked up behind the dash, like it'll be tucked beside where the glove box is. So when you're sitting in a truck, you can't see it anyways. And if you ever, I don't know, say you're driving around and your wipers stop working, You can just open the door, sit on the running board, and it is conveniently located to change your fuses. And it uses plain Jane ATC fuses that are available everywhere. So it just makes stuff a little bit easier if you actually plan on driving the vehicle a lot. Another trick that I stole from newer car wiring, I've also added like a main fuse on the battery feed wire, just that way if ever there's anything major, like a major short that happens on that cable, again, instead of having electrical fire, you just burn the big fuse, and that's all you need. I hid it behind the dash just because the holder is a big plastic thing, and I thought it would look kind of unsightly in our truck. It wouldn't look period correct, so I hid it behind the dash. That's about it.